Good morning, everyone. Here we have an Indramat servo drive, and it is model DDS02 1-W100-D. Now we have two types of feedback for these drives. We have a digital feedback and resolver feedback. When you see a -D, that means it's a digital feedback from the motor. And when you see a -R, it's resolver feedback from the motor. Before we get started, let's make sure our IGBT is good. Let's set our meter to diode test mode. We'll put our red lead on L-, that's bus ground. Here's A1, that would be U. A2, that would be V, so far so good, and A3, that would be W. Let's go back again. 0.396 on A1, 0.398 on A2, 0.396 on A3. Now let's put our black lead on L+, that would be bus plus. Now let's go to bus ground just to see what that measures like. 0.735 bus ground with the red lead. Here's A1 with the red lead, 0.396. A2, 0.397 volt diode drop. A3, 0.395 volt diode drop. Our IGBT and our DC bus look good. Now we're going to pull the cover and see what it looks like inside. So we'll see if there's any obvious damage. There's a screw under this warranty sticker. To get inside, we have to remove that screw. Let's see if I can get on it. It's here someplace. There we go. There we go. I see some shipping peanuts inside. I had to blow those out. It comes in through the vent holes. They'll pack these drives with peanuts, and just to keep it from bouncing around inside the crate. They'll come in through the vent holes. Okay, I don't see any obvious damage. Up here are 3 dual IGBT power modules underneath this firing board right here. Okay, it looks like it's been recapped at one point. These are not Indramat capacitors. Now this one is. This one here is. You can see that it's still got the sealant. Yeah, that one is. Still has the sealant to hold it down to the board so it's not wobbling around. But these up here, they've been replaced before. What we're going to do now is we're going to connect this servo drive to the Indramat bus power supply, connect a motor to it and power it up and see if we get alarm 88. Okay, here's our motor. Take this back off here. You've already got that hooked up on the motor side. We'll hook up the line wires to the bus power supply. Come on. I'm doing a lot of moving today and not getting anything done. It's a slow day anyways. I use wire nuts to connect the 220 line to the line input of the bus power supply. The wire nuts are really nice. I don't think I'd use wire nuts in the machine though. They could come undone and create you all kinds of troubleshooting problems. But just here on the tech bench, nothing's vibrating, nothing's moving, nothing's going to come undone. There we go. Here's my feedback cable. Let's get these out of the way. this green and black wire, is to release the brake. And when we enable the drive to run, or not actually run, but go into holding torque, the brake will be released. This part right here always gives me fits because there's 2 keyways in this connector and 2 receiving keyways on the motor, and I can't never get them lined up. Been doing this long enough, it should be fairly easy. It's probably because I'm trying to do it one-handed. Come on. Come on now, don't be stubborn. Here, I'm going to turn the camera off so you all don't hear me cuss. Okay, we'll be back when I get that connected. I turn the camera off and it goes right on. Move these out of the way so I don't spill them off onto the ground. Okay, there we go. Okay, we're going to see what we got right now before we go any farther. We should see alarm 88 in this 7-segment display right here. There's 2 7-segment displays that show us the alarm. We'll get the camera and we'll move it over there so you can see what it looks like when we apply the line voltage. Let's see what we get. Now, we're going to be upside down. It's the only way I can get the camera in here, but that's okay. We'll see what we get. Yes, we do. Alarm 88. We're going to have to go in and see if we can fix that. What I'm going to do to begin with, I'm going to swap out the control board. That's where the feedback comes in to the control board. And I can do that because I have a control board right here from a blown up Indramat drive. Now this one is also a digital feedback board. Then we'll power it up again and see if we get that alarm 88. Maybe we will, maybe we won't. If we do, then we have to go deeper into the drive to find out why we're getting that alarm 88. So to begin with, let's pull the control board from this drive. Mark the thermal wires 1 and 2 with our Sharpie. Just take those off. While I got this control board off, I'm gonna blow all that styrofoam out. Styrofoam, packing foam, got down inside this drive. Okay. There's the old control board removed. Let me take the drive over to the air compressor and I'll blow out all the styrofoam, the packing foam that got down inside that drive. There we go. Let's install our good board. Put a little insulator here so 24 volts from these power supplies does not short out onto the control board. Let's see what we get now. All right, we're applying 220 volts AC three-phase to the Indramat bus power supply. '88 again. So we know it's not the control board. The chances of both boards having 88 alarm is infinitesimal. You know what? Let's disconnect the feedback from the control board and let's see what we get. '88. Interesting. So with the feedback disconnected, we get 88. With two control boards, we get 88. Very interesting. Here is the circuit that supplies 8 volts DC to power up the encoder. We have an input to the L78M08CV, and that input comes from the power board. This ribbon cable XI8 on pin 1819 is the positive input to that voltage regulator. 2, 4, 6, 8, 10, 12, 16, and 22 are the ground, pin 2 of that voltage regulator. The output, the 8 volts DC output, goes to pin 12 and 5, and ground is on pin 4. We also have another connector, X7. This goes to the I/O board's backplane to power up those I/O boards. Now, let's look and see what our voltage to the input of the regulator and the output of the regulator reference to pin 2 ground. We'll see if we have good solid 8 volts DC right here. And if not, we'll go look at the input and see what that looks like. Here's the ribbon cable from the power board, and that feeds this 3-terminal regulator right here. The input is pin 1, pin 2 is ground, and pin 3 is the output. And the output, 8 volts DC, powers up the encoder. We're going to take a look at the input and the output reference to ground. I've got the scope's oscilloscope ground connected to the heatsink assembly. That is our ground reference. Let's get in front of that oscilloscope and we'll see what that voltage input and output looks like. All right, let's power up the drive. Hopefully this is our problem. We shall soon see. Oh yeah, look at that. That's supposed to be a good 8 volts right there. That is why that encoder is not working. And we're getting alarm 88 on the drive. That looks like a nice swim in the ocean if you're a surfer. Let's go look at the input. That's pin 3, the output. here's pin 1, the input. That should be plus 15 volts DC right there. It looks like we found our problem. We have to go into that power board and see why those supplies are not working. All right, we'll save that for another day. It's getting late. Amazing. There we go. We can fix it. We can fix it. We'll see you tomorrow. Have a good day, all. Enjoy the time on this side of the dirt. Don't you love troubleshooting? We're going in. Okay. There's the gate emitters disconnected. Mark the black wire black. Mark this black wire red. That way I can get them hooked up correctly. Here's an adjustable voltage regulator, part number LM317T. Here's a switch mode power supply IC. It's labeled UC3825N. See where this one leaked onto the board. clean up this board here. Clean that board up just a little bit. There we go. There we go. There we go. Put this back together. We'll try it again. Black, orange, orange, black. Okay. There. Black, orange, orange, black. Black, orange, orange, black. Black, orange, orange, black. Okay. We're hooked up enough to see if we've cleared our alarm 88. Let's get closer to that 7-segment displays. And if all goes well, we'll hook that motor up and we'll run it. All right. Wish us luck. Here we go. All right. AB. AB. Good job, folks. Looks like you fixed another one. Let's hook up this motor and we'll try to run it. Hopefully we don't bump into any other problems. Let's power down and we'll hook up that motor. Good job. Very good job. You've resurrected another one from the dead. All right.